Okay guys, so after natin ma-discuss yung concept ng flow rate and ng Bernoulli's energy equation, so ngayon, i-discuss naman natin yung concept ng hydraulic and energy grade line. So guys, this is the graphical representation that shows the energy head in a hydraulic system. So the first one is the hydraulic grade line, or also known as, o mas kilala sa tawag na HGL. So the HGL, so this is the graphical representation of the total potential energy. So ano ba yung total potential energy in a hydraulic system? So again, the total energy in the equation is equals lang saan nga? So E sub T is equals to B squared all over 2G 2G plus P over gamma plus Z. So, ayan. So, guys, tandaan that yung term na B squared over 2G, so ito yung term kung saan siya ay function for kinetic energy. And yung remaining term, so that will be the function for the potential energy. So guys, i-share ko lang, yung palatandaan ko kasi dito, when we say kinetic energy kasi, di ba from the term itself, kinetic, gumagalaw kasi siya. So, isang palatandaan ko dyan, kaya nalaman ko na ito is kinetic, is itong si velocity. Di ba ang velocity mo, ang tendency niyan is para gumalaw. And for potential energy, so papasok yung si pressure at the same time yung Z or yung location niya with respect to sa reference line. Okay? So, ang potential, di ba, sa dynamics nyo, meron tayong tinatawag na yung equation, yung MGH. Kung saan yung H mo, yan yung location niya from a reference point. So, parang kapareho lang din siya nung sa Z mo. Okay? So, anong nangyari lang, again, ano ba ang definition natin kay hydraulic grade line? So, this is the graphical representation of the total potential energy. Meaning, itong term na V squared over 2G or for the kinetic energy, so ito will be equals to 0. So, for the hydraulic grade line, so that will be equals to P over gamma plus Z. So, ito lang yung term na consider for the hydraulic grade line. So, meanwhile, for the energy grade line, so, or also known as the EGL, so this is the graphical representation of the total energy. So, again, total energy nga, so ibig sabihin, yung EGL mo, so kasama na lahat yung term na yan. So, V squared over 2G plus P over gamma plus Z. Naglolo ko na talaga yung ano ko. Ayan, ayaw nang gumana. Over Z. Ayan. So, ito yung consider mo kapag energy grade line. So, para mas maunawaan, i-discuss natin siya using this figure.
Para sa unang scenario natin, merong tank o reservoir, say continuous ang supply ng liquid sa tank at constant lang ang height ng liquid sa loob ng tank. So yung reference dito na isi-set natin ay situated somewhere below sa bottom ng tank. Sa bottom part din ng tank ay may installed na pipeline within a substantial length at yung other end ng pipe has an opening. So, iset natin as point 1 yung surface ng liquid sa loob ng tank. At yung vertical distance from the liquid surface hanggang dun sa datum line ay Z sub 1. At iset naman natin na yung jet sa pipe opening as point 2. At ang vertical distance from the jet hanggang sa datum line ay Z sub 2. So at some point in the pipeline ay maglalagay tayo ng piezometer. So kung maalala nyo na ang piezometer ay pang-measure ng gauge pressure. At yung point kung saan tumapat ang piezometer dun sa pipeline ay iset natin as point A. Ngayon, sabihin na natin close muna yung pipeline at i-cut natin yung flow sa opening. So mangyayari lang, ang magiging level ng liquid sa piezometer ay same level din sa tank. At dahil ito sa Pascal's principle. Pero mangyayari lang yon kapag close yung pipeline at sa madalit sabi, static yung system. At since open yung pipeline, ay magfo-flow na yung liquid sa pipeline. At dahil dito, maapektuhan na ang pressure sa linya kasi may velocity na sa system. So kung maaalala nyo sa concept ng Bernoulli's energy equation, ay bumababa ang pressure once na mag-flow at may flow velocity na ang fluid. And to illustrate what will happen to the pressure from source or from tank or reservoir as it approaches a pipe opening, so kung papansin nyo, bumababa yung pressure in a linear manner and it is slow. So dahil ito sa velocity at related din dito ang head loss kasi may na-encounter na friction ang liquid from the walls of the pipe. So habang humahaba ang run, ay bumababa ang pressure at once na ma-reach na yung pipe opening o yung jet, ay magiging zero na ang pressure since hindi na confined yung point sa jet. So yung intersection ng na-create nating line at ng piezometer ay yun yung level ng pressure at point A. So yung height from point A hanggang sa liquid surface ng piezometer represents the pressure head at point A. At yung height from the datum line hanggang point A represents the elevation head Z. So after natin maglagay ng piezometer, ang sunod na may maglalagay pa din tayo ng small tube na similar din sa piezometer. So ang kaibahan lang nito ay papasok pa natin yung small tube sa loob ng pipeline at i-intercept yung flow by bending the tube 90 degrees and the opening of the small tube is directly receiving the flow of liquid. So ang tawag natin dito sa tube na to ay pipette tube or in some reference ay stagnation tube. At since in-intercept ng stagnation tube ang flow, ay hindi lang pressure head yung energy represented by the level of liquid inside the tube. So involved na din dito yung velocity. And to further illustrate, gagawa tayo ng line above the broken line na ginawa natin kanina for piezometer. So, nasa ibabaw yung line kasi since na-involved ng velocity head, ay may additional energy na tayo sa line and not just pressure only. So kung titingnan natin sa illustration, yung vertical distance between the liquid surface sa stagnation tube at yung na-draw na continuous line o solid line hanggang sa intersection ng stagnation tube at na-draw na broken line represents velocity head. At yung height from the center line of the pipe hanggang sa intersection ng stagnation tube sa na-draw natin na broken lines represents pressure head. At syempre, yung height from the datum line up to the center line of the pipe represents elevation head. At dahil slope yung line at nabanggit kanina na bumababa ang energy habang humahaba ang run ng pipe, ibig sabihin lang na yung height from the initial level of the reservoir hanggang sa line that represents velocity head, yun yung head loss o pressure drop. And going back to our topic, so yung broken line represents hydraulic grade line since it only shows the level of pressure head. And the continuous or solid line above the broken line represents the energy grade line, knowing that the line shows the velocity head and not only the pressure head. So ngayon ay expand pa natin yung scenario. So ganun pa rin, involved pa rin yung tank o reservoir at meron pa ding liquid sa loob ng tank. So continuous pa rin yung supply at may substantial height yung liquid sa loob ng tank. So sa lower part ng tank ay merong series of pipelines. So yung unang pipeline ay may diameter uppercase D, no? So just to indicate that it has higher pipe size than the next pipe. So yung sunod na pipe ay magre-reduce tayo ng size from uppercase D to lowercase d. At after nung pipe na with lowercase d ay babalik ulit tayo sa size with uppercase d, no? Tulad nung first pipe kanina. So at some point, the first pipe ay may pump. At some point at the second or small pipe ay may valve. At some point naman, at the third pipe ay may turbine. At yung end ng run ay may constricted opening which is in other terms is called nozzle. So, nakuha ko lang tong figure na to from matalino.com at take note lang na hindi practical yung ganitong setup. Syempre, ginawa lang to for educational purposes at para maipakita ng maayos yung concept ng hydraulic grade line at energy grade line. So kung ipa-plot natin ang hydraulic grade line, ay hati-hatiin muna natin ang linya. Sa isa pipe muna bago mag-enter ng pump. So yung hydraulic grade line is sloped down as it approach the pump. Ngayon, kapag ka nakapasok na ang fluid sa pump, ay biglang tumataas ang pressure. Kasi alam natin na ang pump ay nag-i-increase ng energy sa system. So, paglabas ng liquid sa pump, ay in high energy na ang liquid. So, balik flow na ulit ang liquid sa part ng first pipeline. So, ganun pa rin. As the run gets longer, the pressure decreases due to head loss. At ngayon, magta-transition na o magre-reduce na ang pipe size from uppercase D to lowercase d. So, i-reminisce lang natin yung concept about Bernoulli's energy equation. So, nag-reduce ng size yung pipe. So, it means that velocity will increase. And thus, pressure will be decreased. So, meron ding relation ng head loss dito. Kasi proportional ang velocity to head loss. Pero i-discuss natin yan sa sunod pang mga videos. So, dahil bumaba ang pressure, ay pa-plot natin yan sa hydraulic grade line. So, ganun pa rin. Slope down pa din ang hydraulic grade line once na ma-reach natin yung valve. At magdadrop ulit ang pressure. Kasi, kung maalala nyo, isa rin sa mga nakikreate ng head loss, yung mga existing valves and fittings sa system. At after ng valve, ay magsuslope down pa din ang hydraulic grade line. At since mag-increase na ulit ang pipe diameter from lowercase d to uppercase d, ay bababa na ulit ang velocity at tataas na ulit ang pressure sa pipe. Kaya kung mapapansin nyo, biglang nag-rise ulit ang pressure sa hydraulic grade line. So ganun pa rin, mag-slope down pa din ang hydraulic grade line hanggang mag-enter ang liquid sa turbine. So kung maalala nyo, ang function ng turbine ay extract ang incoming hydraulic energy. Kaya magdadrop bigla ang pressure from the turbine. At paglabas sa turbine ay mag-slope ulit ang hydraulic grade line. And as the liquid approaches the opening of the nozzle, ay magiging zero na ang pressure. Ayun, so i-trace muna natin yung na-construct natin na hydraulic grade line. So bale, yung vertical distance o yung height from the center line of the pipe up to the plotted HGL or hydraulic grade line represents the level of pressure head in the pipeline. Ngayon naman ay plot na natin ang EGL o energy grade line. So same pa din. I-plot natin ang EGL above hydraulic grade line o HGL. Since i-consider na natin ang velocity head. So yung ipa-plot natin ay mula sa source hanggang dun sa transition ng uppercase D to lowercase d. So, ipa-plot natin yung sa part ng transition na hindi tulad ng sa HGL wherein nag-depress ng sobra yung pressure head. Tandaan, nabababa talaga ang value ng pressure sa area na ito dahil sa pagtaas ng velocity head. At syempre, bababa din ang EGL dahil sa head loss. So, tuloy-tuloy lang ang plot. Pero kung mapapansin nyo, ang plot natin sa opening ng nozzle ay hindi umabot sa zero. Kasi may velocity pa din sa jet ng liquid. Ito ay dahil hindi confined ang liquid, kaya zero na ang pressure sa point na to at zero din ang value ng HGL. So, ayun. Trace lang natin yung nagawa nating EGL. So take note lang na yung vertical distance from HGL to EGL represents velocity head. So madalit sabi, ang difference between EGL and HGL is velocity head. So yung height difference at EGL from the entrance to the exit of the pump is HP or head added by the pump. At yung height difference from the entrance to the exit of the turbine at EGL is HT or head extracted by the turbine. At take note lang din na yung difference in height sa maximum at minimum point ng slope line ay yun yung head loss from pipe friction. At yung pagdepress ng line at valve ay dahil naman sa minor head loss from valve. So, ayun. So, ito yung energy grade line. At recall lang natin na ang energy grade line is also equal to the total energy head, or it is equal to V square over 2G plus P over gamma plus C. At take note lang din na yung difference in height ng center line of the pipe hanggang sa EGL ng nozzle, opening, or jet represents the velocity head of the jet. And that would be all. Thank you so much.